Welcome to another episode of my construction videos, and we are still talking on the topic of bending schedule. We are still doing bending schedule, and we've done the first part, the second part, and this is the third part where I said I will be showing you the method in doing bar bending schedule. So in this video, I'm going to be showing you the method in which you can do bar bending schedule. And over the years on site, I've been using this method, and especially the second method which I'm going to teach you, and it has been very helpful on site because you are going to get the actual number of enforcement needed for the job. I hope by the end of this video you are going to know how to prepare an efficient bar bending schedule that's going to cater for all your need of enforcement, and you are not going to need have a course to request for more enforcement on site. So join me and let's begin. Just like I said, that the video is still on bar bending schedule, and I titled this as a simple method of preparing a bar bending schedule. So let's begin. So the content of this video will be method of preparing a bar bending schedule and an example on the methods. So just as usual, I like giving an example, so a practical example rather. So it's going to be very simple for people that don't know it and people that want to know more. So it's going to let's say alternate to practical, because you are not doing the practical now, but it's probably the alternate to practical, which will be very helpful on site. So let's begin on the method of bar bending schedule. So from what I have here, I said there are two methods of preparing bar bending schedule, which I title as the total length method and the number and off cut method. So I said it is total length method, then the numbers and off cut method. So the total length method is just the method everybody use, and the method everybody use in doing their bar bending schedule, which is to get the length of the enforcement and to multiply that the quantity you need. Let's say you need a 3.5 meter enforcement and you need uh probably 10 of it. So you just do 3.5 multiplied by 10, which is 35 meter. That is what I mean by the total length method. This is the method everybody use in doing bar bending schedule. Then the number and off cut method. The number and off cut method is the method I discover while doing bar bending schedule, and at the end of the day you still have some shortage on site, some shortage of enforcement, and this is going to set the project finishing time. It's going to set it backward because you need to request for additional enforcement and you need to wait, you need to spend money on additional cost of transportation before getting the enforcement, and it's going to delay the job probably by 2 or 3 days, depending on the quantity of enforcement. So I developed this method so it will be easier for work on site. When you use this, it's going to give you the number and off cut. I'm going to do an example on it in which you are going to is going to be very easy. And the number and off cut method I think is very useful in a small scale job. A small scale job, as in a job that the fund is not much. Probably a job where the client does not have much fund and is interested in the material he's using. So if you use this number and off cut method, it's going to give you the quantity of enforcement you need. And as a contractor, you are not going to fall short, or an engineer, you are not going to come short of the number of enforcement you need, because if you use the total length method, you just need to add a percentage to it, which might not be even right. The percentage you are adding for off cut might not be right. But when you use the number and off cut method, you are going to have the accurate number of enforcement you need. So from the note I have here, the total length method, I said this method involves using the measured length of the bar for quantification. Here, the length of the bar is multiplied by the number or quantity, then summed together at the end of the calculation. Then the conversion to kilogram or tonnage is done, just like I have said. So in this method, after multiplying, you just convert to tonnage, and you convert to tonnage or kilogram or length. And this method is mostly used by quantity surveyor and in large project. Now, in large project, just add a certain percentage. A certain percentage may be added for off-cut, and this percentage are not just like what I said. This percentage you are adding to it are not certain that this is the actual. You might be getting more, or might be getting less. If it is a large project, yes, you know that if you are getting less, if it is not that much, you can request. You can use part of your money. Probably you have excess somewhere. You can use it in you can cover for the shortage of enforcement, and you can even have more. But the number and off-cut method is going to give you the accurate you need. So I said this method involves calculating the length of bar required and the off-cut the bar will produce. So you get the length of the enforcement and the off-cut it is going to produce. So using this method, we are going to know the length we need, the enforcement we need, and the off-cut we are going to have at the end of the job. So this method gives the actual quantity of bar without the addition of a percentage for of course. It is best for small projects and projects where waste is minimal or low funded project. So this method, I think everybody should adopt it. It just give you the quantity of enforcement and the off cut you are going to have, so you don't need to be adding another percentage you are not sure of. And just like I said, it's mostly used for small, even large project can adopt it. If large project adopt it, you know the quantity you need from start to finish of the job without additional cost. So those are the method of preparing biochemistry schedule, and I'm going to do example on them just like I've always been doing. We are in AutoCAD to do the calculation. So I've done for this is the total length method, and this is the number and of cut method. So I've done for the total length method. If you watch my last video, I did for total length method. I use this first beam here to do this first part here. This one I label 1 to this area here. Then I use the second beam to solve for this. So in this video, I'm not going to be doing the total length method again. You can refer to the previous video on this bending schedule. You get how I come about this. Now I want to do that of the number and of cut method. Then I'm going to compare the two answers, the two number of enforcement we have, and you are going to see the difference. Now this is it. I just copied this from this. I copied this from this, so I won't be doing anything strange here. I just copy and I added new columns. So if you see here, we have beam, we have the bar mark, we have the beam, we have the diameter length, quantity. So I changed the total length from the previous table to number of bar. Then the shape still remain the same. Then I added another column for off cut, if you see. So I changed this here to number of bar, then I added the off cut. So let's start from here without wasting much of our time. Then let me use the number and off cut method to do this that I did in the previous video. Now let's start to save our time. So I want to do this beam. The top bar is 16 mm bar, and I need 4.54 meter length. That is 4540 millimeter length of reinforcement. So what I will do, a length of reinforcement is 12 mm. So how many length of this can I get from a 12 mm reinforcement, right? So let me use my calculator for me. I can say 12 minus 4.54, no, 4 point, okay, 54, I will have that, then minus another 4.54. So meaning this is two length. The last length cannot take 4.5. So what I need is three length, two length rather, two length. So I will have this off cut and I will have another off cut. So let me come here, let me copy this. Meaning for this job, I need two length of reinforcement. From that two length of reinforcement, I'm going to have an off cut of 2.9292. Then from the other length, that is 12 mm minus 4.54. Nice. Let me use my calculator. 12 minus 4.54. I have 7.4. 46. 7.46. 7.46. So meaning from this job, I use 2 length of reinforcement and I have this off cut. Now coming to this, I still need 16 mm. I need 2.1. That is 2.1 meter in 2 places. I need it for the job. So I can just come here. I don't need a new reinforcement for that. I can just remove this. So if I remove 2.1 from 2.92, I'm going to be left with 0.82, right? Copy and just have it here. 0.82 is the length I need. Then I need one length. No, I still don't even need any length. I've removed one from this, so I have this off cut. Then from this 7.46, I can still remove the remaining 2.1. So I can just say minus 2.1, which will give me 5.36. 5.36. Let me use this. 5.36. Meaning for this second job, I don't need any reinforcement, so I can just come here and put dash so that I won't go back to it. So I know from this work, I don't need any reinforcement because I'm going to use the off cut from this to do this job. So these are my off cut now. No, now I can come to the third one. I have 3.8. I need 2 length of that, and I have 5.36 here. So what I need to do just to remove 3.8 from 5.36. 5.36, then minus 3.8. Minus 3.8. I have 1.56 remaining. 1.56. 1.56 left. That's from that 1.5. I just remove one of this, so I need another one, which means I need one reinforcement from this job. Then I'm going to have off cut because this other off cut cannot cover for this, so I just need to have one reinforcement for the job. Then 12 meter minus 3.8, so 12 minus 3.8, I'm going to have 8.2. 8.2. Then if I just copy one of this, 8.2. So I have this of cut left. I have this of cut. So I've just used 3 reinforcement and I have this of cut. So I can come to the next job. I need 7.7 reinforcement and I need 2 length. So I can just remove 7.7 from this in particular. So I will have that should be 500 left. Copy. I can bring it down. I have 0.5 reinforcement left for that job there. Can still bring this down. Then I still need one reinforcement to cater for the other length of the 7.5. So it means I need one reinforcement for this job. And if I remove 7.7 from 12 I'm going to have 4.3. That should be 4.3. Copy. So I have 4.3 left. So these are my present off cut. Now I've used just 4 reinforcement for the job. Now coming to the 12 I need 7.1 length and I need 6 numbers of it. So looking at this, it means I need 6 reinforcement for this job. 6 reinforcement for this job. Then out of those is I'm going to be having an off cut of 4.9 meter. 4.9 meters for off cut. So I said I need 4.9 meters. Yes, so I need this of it. So I can come to this runners. I need 2.12 length and I need 30 of it. So, but from one length, how many of these can I get? It will be 5. Then with some off cut, how do I know? It's going to be 2.12, then multiply by 5. I'm going to have 10.6. 10.6 cannot take the other. Let me add it plus 2.12. I have 12.72, and a reinforcement, you cannot see any reinforcement of 12.7. The highest you see is 12 meter. So it means I need 5. How do I calculate it now? I need 5 reinforcement I need 6 for this job rather, because from one length of reinforcement, from one length of reinforcement, I'm going to get 5. So 5 multiplied by 6, I'm going to have 30. So I'm going to have off cut of, that is, what do I get? Okay, let me take it again. 2.12 multiplied by 5. So I have 10.6. So I'm going to have off cut of 1.4 left. Off cut of 1.4. Copy. So I'm going to have 6 1.4 off cut. Then here I'm going to have 6 4.9 off cut. Then these are the many off cut for this job. So I can come to the second part here. I have let me now do is something I've done. That is, I'm through with the number and of cut method and the total length method. Now let me compare the number of enforcement we have for the job. Now from this, let's count the number of enforcement we need for this job. So for this job, we need, for 16 we need 6. Is it for, okay, for 10 rather, we need 6, and we need 6 here, making 12. Making 12 lengths. 12 length. Now for the 16 I need, this is 3, 4, 5, 3, 4, 5, 6, 7, 8, 9. 9, that is 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I need 18 length for this. 18 lengths. But the reason why I don't do that of the 12 is because I don't have 12 here, so I don't want to incorporate it here. So the video I will not need to be wasting time on the video. So let me just go with what I have there. I don't want to compromise what I have from the previous video. So looking at this now, let's say from what we did last time in the part 2 of this video, the total length of 10 I have 138. So how do I get the number of length I need? That is 138 divided by the length of one reinforcement, which is 12 So 138, we do 138 divided by 12. So I have 11.5. Let me even copy that. Yeah, I have 11.5. And for the 16 I have 84.4 divided by 12. I'm going to have 84.4 divided by 12. I have 7 lengths. I'm sure you have seen the difference in the. I'm sure you have seen the difference already. The 7 length. Now looking at this, for the total length method, the method I said everybody use, that we just multiply the length by the by the numbers we need. Let's say we need 3.5 meter reinforcement and we need it in 10 places. That is 35 meter, right? Now, if you are using total length method, what you just use is 35 divided by 12, right? Which is 3 length of reinforcement. That is what this gives us. When we use it, we have 10 mm of 11.5 and 16 of 7 length. But when we are using this method tells us that we need 18 length of 16 mm reinforcement and 12 length of 10 mm reinforcement, and this is our off cut. That is what this job is telling us. So let's say, just like the instance I made, I purposely made the instance. Let's say the instance we made for this, when I say we have 3.5, we want to get 3.5 length of reinforcement in 10 places. For this, is telling us we need 3 length of that reinforcement, 3 full length. But this method will tell us that you can only get 3.5 reinforcement, you can only get 3.5 reinforcement from one. That's if you add it together, you are going to have, that is 3 plus 3, that is 7, plus 3.5, that is 10.5, and you have an off cut of 1.5 meter. That if you are getting 3 from one length and you need 10, that is, you need more than 3 reinforcement for this job. That is what this method is telling us. Now, if you use this method, you need 18 length of 16 reinforcement. So in case you are using this, or you are used to this method and you calculate, if you didn't have add any percentage of waste, we are still going to have a shortage. Now, there's no amount of waste we want to add to this. Let's say we want to add 10% to this, we will still not get 18 meter. And what quantities of your cost manager do is they will add a particular percent, and the percent of waste they do add is from 5 to 10%. So let's say we want to even add 10%. 10% of 7 meter, is that not 0.7? Yeah, is 0.7 plus this. We are going to be having 7.7, and we need 18 length for this enforcement. So that's just a comparison between the two methods I use in doing bending schedule. And since I've noticed these discrepancies, this is the method I always adopt, even when I have a wood job ahead of me. This is the method I use because I know this method is going to give me the number of enforcement I need and the off cut. So in case I leave the site and probably I came to check the work, I know the number of off cut I should have, because I gave you the bending schedule and I told you use this bending schedule for your work. I came, you use my bar bearing schedule to do your work, and I know the off cut I will have on site. So that's it. Just one way of monitoring your job. I said it in the part one when I started the video that project manager and engineer use it for supervision and monitoring of their work. So that's just the difference between the numbers and off cut method and the total length method. So I hope you find this video interesting. So if you find the video interesting, you can give me a like at the end of the video, and if you have any question, you can put it in the comment section. I'll be glad to attend to them. Thank you for watching.